This is the Algebra 1 spiral, talking about simplifying radicals. There's several ways to simplify them. There's the prime factorization way, and there's the just knowing your perfect squares. I'll try to show you both of those ways for the most part on a lot of these, but it's going to take a while if I do both ways on all of them, so I won't do both ways on all of them. I'll try to do both ways on some of the first ones though. Square root of 50 m cubed. You should split this square root of 50 times square root of m cubed. Now, one of the ways is to just know a perfect square is 25 times 2. 50 is 25 times 2. Square root of 25 is 5, so this is 5 rad 2. You also should know that m to the third is the even amount and the leftover. Square root of m squared is m rad m. So put the stuff that is radicals, the things that have to stay home by themselves, and 5m, so it's 5m rad 2m. You also could have done the prime factorization way. So 50 is 5 times 10, 5 the prime. 10 is 5 times 2, they're both primes. Every time you have a pair, they get to go to the prom, 2 stays home. M to the third, you could technically deal with this. It's m and m and m. There's a pair, it goes outside. There's one solo, it stays inside. Still we get 5m rad 2m. Number 2, same idea. Let's just do the prime factorization way. It is 8 times 10. 8 is 4 times 2. 2 is a prime. 4 is 2 times 2, both of which are primes. 10 is 2 times 5. This is a pair, it goes on the outside. Here's another pair, also goes on the outside. One solo 5 on the inside. M is a solo, so that definitely goes inside by itself. N to the third. Now you could do the whole spread out 3 n's and make this n and n and n, and you have a pair, it goes on the outside, and a solo, that goes on the inside. Well, you really need to know, because once these exponents get super high, you just need to know how many pairs can I make if I have 3 things. That's one pair with one left over. You gotta know how to do that. I'm not done. Stuff that's inside the radical, the 5, the m, and the n, 5m, n, go under together, and the 2 times 2 is 4 times n is 4n. So it's 4n rad 5m n. 3 is different because now we're not looking for square roots, we're looking for cube roots. We're looking for cube roots. 375, let's break down 375. 375 would be 25 times 4, 8, 12, 15. Right? 25 times, no, excuse me. I was right, 15. Neither of which are done. 25 is 5 times 5. 15 is 5 times 3. Now in this case, when I'm looking for pairs, since it's the cube root, we're looking for a triplet. There's a group of 3, goes on the outside. One solo 3 is the cube root of 3 by itself. A to the third, again, we're looking for groups of 3. Well, A to the third is a group of 3, goes on the outside. One solo B still on the inside. The stuff that go under the radical get moved to the end, 3b, and the stuff that's not, 5a, get moved out front. 5a cube root of 3b. So you need to know how to do the prime factorization, and the perfect square way also works as well. For number 4, don't get confused. If it's just 5m out front, we're just going to multiply by 5m at the end. So let's break down 200. You could do 2 times 100. 100 is 2 times 50. 50 is 5 times 10. 10 is 5 times 2. So it's a nice long way to do. Well, 2 times 2, that's a pair, goes on the outside. 5 times 5, that's a pair, goes on the outside. So 2 times 5, and then rad 2. So it's 10 rad 2. Now if you got 10 rad 2 for square root of 200, but if you had known how to do the not necessarily prime factorization way, but if you knew how to do it the perfect square way, it would have been a lot quicker. Let me show you. Square root of 200 is the square root of 100 times 2. So it's 100 times 2 is 200. Square root of 100 is 10, so it's 10 rad 2. A lot quicker, a lot easier. M and N are solos, so they stay. There's no way they're going to pair up. Since they're under the radical, 2mn go under the radical together, and then this is the only thing you have to do. 5 times 10, that's 50, and then n. Don't get confused, just because there's numbers out front just means to multiply at the end. Number 5 is asking us to, again, do the cube root. The best way to do cube root is to break it down and do the prime factorization. Let's break down 320. 32 times 10. 10 is 5 times 2. 32 is 16 times 2. 16 is 8 times 2. 8 is 4 times 2, and 4 is 2 times 2. So a lot of 2's in there. Let's look for triplets. Here's a triplet, which means that 2 goes out front. Here's another triplet, 1, 2, and then that 2. So that goes out front. And then there's 1, 5 by itself. Remember, that's the cube root. Again, with a and b, while it's nice, it's b squared, you might be tempted to pull that out. We're looking for triplets now. So it's the cube root of ab squared. Those stay because we're not going to have triplets with 1a and 2 b's. 2 times 2 is 4, and then it's the cube root of, all this stuff goes back in together, 5ab squared. 4, cube root of 5ab squared. Number 6 requires us to break down each part, or a better way is to, well, leave the 5 out front so we don't forget. Let's put these back together. So since we're allowed to split radicals, 200 is rad 100 times rad 2. We could also put them back together because rad 100 times rad 2 is 200. We can multiply them back together. Let's multiply them back together. By that I mean 10 times 75, since it's both under the radical, is 750. M times m squared is m cubed. P times p, well, let's put it in alphabetical order. N is next. P times p is p squared. Again, don't forget to multiply by 5 at the end. But let's break down each of these parts. Let's do 750. I'll do it right here. Square root of 750 is, I'm going to do it my way, 25 times 30. 25 times 30 is 750. Square root of 25 is 5 rad 30. There's no other perfect squares in 30. 1 goes into it, but 4 does not. 9 does not. 16 does not. So it's 5 rad 30. This is 5 times 5 rad 30. M to the third. If we have 3 m's, that's 1 pair and 1 left over. Rad n remains rad n, and p squared, if I have 2 p's, that's 1 pair that can be brought out. Let's put the under the radical stuff back together first. 30mn. 5 times 5 is 25. M, and then a p. 25 mp rad 30 mn. You want to break down 750, you could have done that. 75 times 10, yada, yada, yada. You would have ended up with 5 rad 30 in either case. Number 7. Again, just like with number 6, I'm going to combine these and put them back together. Sometimes things get separated. We want to put them back together before we can get going. Since they're both under the radical, we can multiply them. 6 times 14 is 84. M times m is m squared and just 1 m. Let's break down 84. We'll do it over here. 84 is, let's do 4 times 21. 4 times 21 is 84. This is 2 times 2. This is 3 times 7. Obviously, 2's are the pairs, so there's a pair of 2's. And then 3 and 7 go back together to make 21 back under the inside. You could have also done 84. Rad 84 is rad 4 times rad 21. Square root of 4 is 2 rad 21. It's the same thing. Don't forget with your calculator, you can always check these by actually multiplying 2 times rad 21, see if it's equivalent to rad 84. And also equivalent to rad 6 times rad 14. To sort of show you what I'm talking about, we can always multiply a second radical. You kind of see it. You have to look through this. Let me erase this, I guess. Second radical 6 times, let me close these parentheses actually, times second radical 14. And see what I get when I multiply these. 9.165. Let's see the same thing as square root of 84. Second square root of 84. Same thing, so I know that that's the same thing. Let's see if it's the same as 2 times the radical 21, and see if all my answers are the same. And they are. That doesn't necessarily mean I'm reduced, but it does mean that I haven't messed anything up yet. Let's continue going. Square root of m squared is m, because it's a pair, and rad n remains rad n. Under the radical is square root of 21n, and this is 2m. So 2m rad 21n. 8, 16, we could break down 16 as 8 times 2. 2 is a prime. 8 is 4 times 2. 2 is a prime. 4 is 2 times 2, both of which are prime. Since it's the cube root, I'm looking for a triplet. So there's a triplet of 2's and 1 2 by itself. You also could have broken it down knowing that 8 is a perfect cube. So 8 times 2, 16. Cube root of 8 is 2, so 2 cube root of 2. Same thing using either method. Number 9, another one where we're going to put it back together. We're going to put it back together before we can take it apart. Both cube roots, so we can do this. 9 times 27. Cube root of 243. A times A is A squared. B times B is B squared. C times C squared is C cubed. 243. Break down 243. I'll break it down using the prime factorization way for you. 243. Well, one thing I do know is that it's 9 times 27, because I just multiplied that. 9 is 3 times 3. 27 is 9 times 3. And 9 is 3 times 3. 27, by the way, is a perfect cube, so we could have broken it down that way, but I like to put them back together first. 3 3's is 1 3 by itself, and then 2 3's is cube root of 9 going back in. A squared, nothing you can do, so it's the cube root of a squared because it's not a triplet. It's triplets this time, not square roots, so you can't just make it a. B squared, again, it's the cube root of b squared, and this time we have a triplet of c's, so that's 1c. All the stuff that is radicals, cube root 9a squared b squared, back under together, and the c and the 3, so 3c out front. 3c, cube root of 9a squared b squared. Twisting it up a little bit on the last ones, asking us to write the problem backwards to determine what the original was. So we want to find the full radical. If I simplify it to be 3b, that means the question is, what was it before I turned it to 3b? Well, I know that the only way to get 3 must have been that it was a 9, because the square root of 9 is 3. And how could I have gotten b? That's b squared. So I like to write it above. It helps you guys when you see this. So the only way to get 3b was square root of 9 is 3, square root of b squared is b, and the 6a back together. So this is 6a with a 6a. So 9 times 6 is 54. B squared times a is a b squared, putting it in alphabetical order. That's it. Again, the question really is, what would the radical had to have been in order to get 3x squared? Well, how do I get 3? That means it was 9. How do I get x squared? That means it's x to the 4th. Because 4 x's is 1, 2 pairs. And then the 15x goes back up top. So 9 times 15 is 135. 9 is 135. And then x to the 4th times x is x to the 5th. Don't forget the full radical. Last one, again, what would my radical have to have been in order to get 2xy squared? Well, 2 must have been 4, because the square root of 4 is 2. X must have been x squared, and y squared must have been y to the 4th. Bring back up the 15xy, let's put it together. 4 times 15 is 60. X squared times x is x to the 3rd, and y to the 4th times y is y to the 5th. Rad 60, x to the 3rd, y to the 5th. You can always check this, of course, by using your graphing calculator once again, and checking to see, for example, if 2 times rad 15 2 times second radical 15, which is 7.74. So 2 times radical 15 is 7.74. Is that the same thing as the square root of 60? My answer? Let's see, second square root of 60. Looks like it was the same thing, which means square root of 60 and 2 rad 15, 2 times rad 15 were the same thing. So at least I know I'm not definitely wrong.